كده حاليا كده.
Good morning. Hi, this is Dr. Shadi Nabil. We are going to speak today about the hydrocarbon compounds in the atmospheric particulate matter, Alexandria, Egypt. I am the Technical Quality Assistant General Manager at Iprom Amidur Refinery and an environmental and petroleum consultant. Our topic today will be the hydrocarbon compound in the atmospheric particulate matter, Alexandria, Egypt. The climate change, it is now issue in all of the world, which is one of the essential global phenomena that affect the quality of the human life, economy, and welfare in recent years. This phenomena is due to the gradual increase of the long-lived greenhouse gases molecules such as carbon dioxide, methane, ozone, and chlorofluorocarbons, also the hydroperoxide radicals for water vapor, and the nitrogen monoxides, and the chlorofluorocarbons in the atmosphere. This is found due to the high rates of the growth of energy generation and the human overconsumptions and the industrial development in most countries. These so-called greenhouse gases allow the solar radiation in the visible region to reach the Earth's surface, but it do not allow the long-wave emitted radiation from the warm Earth's surface in the infrared to escape to the space. We also know, most of us know that the climate change can impact the air quality, the quality of the air itself. And conversely, the air quality itself can impact the climate change, which leads to many impacts to the local air quality. The atmospheric warming leads to the increased ground level of the ozone in many regions. The impact of the climate change on other air pollutants such as the particulate matter is less certain than ozone, but research is underway to address these uncertainties. All of these issues, this imbalance of radiation reflecting is causing the observed increase in the average global temperature. Almost all these gases are gradually increasing in the atmosphere, except for CFC, chlorofluorocarbons, which were controlled by Montreal Protocol. We could find that, in particular, if we are focusing about the carbon dioxide, has increased dramatically over the last years, from in 2006, from 380 ppm to over 400 ppm in 2018. We could show the following figure. We could find the gradual increase from 380 ppm, and it reached to about over 400 ppm. Also, the temperature increase caused the global land ocean temperature anomaly since 1880, which is increasing. We could find the increase here. So far, for the average global temperature increase didn't exceed 0.85 degree Celsius over the past 100 years. This observed increase in temperature is associated with increase in the sea level due to the melting of the polar caps. The accelerated temperature is also associated with a correspondingly accelerated sea level rise. Here we could find the increase in the temperature and the increase in the mean sea level over the last 15 years. This figure 1A, figure 8, shows the global representation of a temperature acceleration. And figure B shows the global mean sea level from different satellites from the TOPIX and JSON 1, JSON 2. You could find the increase. The red one shows the topic satellite, the increase. You can find the mean sea level for JSON here, and for JSON 2 satellite, you can find the variation in the sea level. Moreover, the rise in the average global temperature is also associated with increase of the frequency, severity, and duration of extreme events. The increased rates of occurrences, severity, and duration of hazardous events such as heat waves, flash and floods, dust storms, and drafts. It was noticed that the increase in the temperature is mostly manifested in the lower troposphere layers, which became the responsible for holding the air pollution in the troposphere layers. This air pollution is causing many health impacts to humans. It is estimated that if there is no action will be done to reduce the greenhouse gases, this increase of average global temperature will reach around 4 to 5 degrees centigrade by the end of this century. If this is not stopped, the sooner the better. Polar caps will completely melt and the sea level will also will rise. And this rise of the sea level may reach over 100 centimeters due to the water from polar caps, which is very dangerous from some cities on the seas. So, to reduce this risk associated with the increasing temperature, it is necessary to mitigate emissions of these long-lived gases, which is affecting the agricultural resources, coastal areas, and cities, and adapt to the changes in the climate. For recently in COP22, the world, about 194 countries, realized these facts and came to a remarkable agreement in Paris 2015 not to allow the global temperature to increase more than 2 degrees centigrade above the present time mean temperature. For Egypt, because of its environmental vulnerability, has presented the case on behalf of about 50 countries in African countries, and Egypt has signed the Paris Agreement in 2015 and ratified it in 2016. The scarcity of available information on emissions of for various countries and the shortage of the capabilities of developing countries and the lack of awareness among diverse communities are the main obstacles facing the immediate solution for such problems, such global problems. The air pollution, mostly the emissions of pollutants in the air, can result in changes to the climate. Ozone in the atmosphere warms the climate, while different components of particulate matter can have either warming or cooling effects on the climate. For example, the black carbon, which is a particulate pollutant from combustion, contributes to the warming of Earth, while particulate sulfates cool the Earth's atmosphere. Nowadays, the air pollution is considered to be the world's largest environmental health threat, accounting for about 7 million deaths around the world every year. Air pollution causes and aggravates many diseases ranging from asthma to cancer, lung illness, and heart diseases. The estimated daily economic cost of air pollution has been figured about 8 billion US dollars, or 3 to 4% of the gross world product. It is estimated in 2021 the deaths of about 40,000 children under the age of 5 were directly linked to particulate matter. air pollution, specifically the PM 2.5. And in this age of COVID-19, it was found that the exposures to PM particulate matter increases both the risk of contracting the virus and of suffering more severe symptoms when infected, including death. In September 2021, the World Health Organization, the WHO, released a timely and ambitious update to its global air quality guidelines. With this update was about 15 years after the last update released in 2006. This update acknowledged the significant impact of air pollution on global health. In this update, the WHO recommended and cut the concentration of the PM10, PM 2.5 concentration by the half, from 10 microgram per meter cube down to 5 microgram per meter cube, which with the ultimate goal of preventing millions of deaths. The worldwide evidence on airborne particulate matter and its public health impact consistently shows adverse effects to exposures that are currently experienced by urban populations in both developed and developing countries. The epidemiological evidence shows impacts following both short-term and long-term exposure. The range of health effects is broad, but it predominantly relates to the respiratory and cardiovascular systems. The entire population is affected, but susceptibility to pollution may vary with health or age. Here, the lungs, we could see the particulate going deep into the lung. A particulate damages the lungs. We could see it here. It is the pathway of the particulate matter through this. Particulate matter is associated with many different compounds, like the polycyclic aromatic hydrocarbons and the normal alkanes, which are major air pollutants in urban environments. These small particles pose the greatest risk to human health. While the nose can filter most coarse particles, fine and ultrafine particles are inhaled deeper in the lungs, where they can be deposited or even pass directly down to the bloodstream. You can find a comparison between the suits and the dust and red blood cells and the human hair to show the comparison between the particulates, a different kind of particulates. The sand. The World Health Organization in 2005 released an estimate that about 2 million premature deaths per year can be attributed to the air pollution and issued stricter worldwide guidelines. While in 2014, air pollution accounts for 7 million deaths around the world every year. The particulate matter concentration in Egypt is currently 5.8 times above the WHO annual air quality guidelines. This is a global map colored by the annual average PM 2.5 concentration around the world. The concentrations, and we can find here the most polluted countries with the PM 10 to 2.5. The population weighted to this figure in 2021, the average PM 2.5 concentration in ppm for the countries and regions and territories in descending order. For Egypt, it is about 29.1 microgram per meter cube. Africa, Chad is one of the most polluted countries, about 75.9 in the African countries. Here, Egypt's about 29.1. The sparse air quality data makes gauging the exact extent of Africa's air pollution problem difficult. It is calculated that air pollution is the cause of an estimated about 780,000 African deaths per year. The wind-blown dust from the deserts is a common source of PM 2.5 pollution in Africa. Also, the fossil fuel combustion, waste, and agriculture burning. It is predicted the African population will be doubled in the next 30 years due to the rapid transportation growth, industrialization, and urbanization, which will have a negative impact on the regional air quality. Based on NASA satellite data, 70% of the world wildfires takes place in Africa. Most of these fires burn through grasslands and generate a large amount of ambient PM. To make matter worse, the fires can occur year after year because they frequently burn savanna. They can regrow burnt grass within a year's time. This savanna. Chad is ranked number one as the most polluted regional city in Africa, with an annual average PM concentration of about 77.6 microgram per meter, which is a value greater than 10 times the WHO air quality guidelines. In 2020, air pollution had returned to record high levels among residents of Greater Cairo, after dropping significantly over the past months as a result of the closures and the curfews due to the outbreak of COVID-19 in the country since the mid of March, where the monitoring stations recorded an increase in the concentration of pollutants in Greater Cairo because of the emissions from vehicle exhausts and public transport, and that also the burning of wastes, which led all of these problems led that the citizens feel the extreme high temperatures and high humidity, and they felt a general discomfort from both inside and outside homes. What are the main causes of air pollution in Egypt? The main source of air pollution in Egypt comes from both PM 2.5 and PM 10. They mainly come from the transportation industry, the opening burning of the solid organic waste material, also given to its close proximity to the desert regions surrounding the country. A large portion of dust is blown in from the surrounding lands. The air quality in Cairo varies between 10 to 100 times more polluted than the worldwide acceptable standards. What can be done to improve the air quality in Egypt? Toward the end of 2020, the World Bank Board approved a 200 million loan to support Egypt's efforts to reduce air quality pollution, mainly in Cairo. This project will focus on greenhouse gases, reducing the greenhouse gases from vehicles, also improving the solid waste management, and strengthening the decision-making system for air quality and climate. Recent studies estimated that the annual economic cost of air pollution to health in the Greater Cairo region alone at 1.4% of Egypt's GDP. In Egypt's Vision 2030, this project will contribute to achieving the Egyptian government's goal of the environment, which is to reduce air pollution from fine suspended particulates by about 50% by 2030. This new air pollution and climate change management projects aims to modernize the Egyptian system for monitoring air quality and strengthening the ability of population in Cairo to cope with the high pollution situations. The release of the massive amounts of pollutants in the atmosphere environment of Egypt as a result of the larger population, the rapid urbanization, and the industrial expansion, and the increased utilization of fossil fuels in automobile trucks has raised serious concern about these potential hazards of these pollutants to the public health. In the last decades, more data on airborne concentrations of these toxic pollutants have become available from many industrialized countries. But for less developed nations and for countries with a predominantly arid climate, the availability of this data is far less. The studies on air pollution have long been advocating various important measures that can be afforded by innovative technology like electrical vehicles or alternative fuels, such as the natural gas can be used instead of the, the gasoline or the diesel. But when put into proper perspective and a foreseen timeline, the impact of fuel quality improvement in air is found to be by far a much higher priority and a prerequisite to many other measures. The current trends suggest that the slow penetration rate of electric vehicles and the natural gas vehicles in Egypt will not be sufficient alone. Using electrical vehicles or using the natural gas vehicles in Egypt will not be sufficient alone to improve the air quality in the coming years if there are no parallel measures to improve the emissions from existing vehicles and their fuels, especially for the cars and trucks using the diesel fuel, which is the primary priority for air quality improvement. For references, the common bench mark is in Egypt is the European emission limits standards. And it is considered that one of the most critical challenges in attempting to reduce the vehicles is the sulfur emissions, which is high, as we could know that the high content of sulfur results in the inhibiting the performance of a vehicle emission control devices, which is used in the cars to reduce sulfur. The average is exceeding about 2000 ppm in Egypt, sulfur in diesel, which is higher than the acceptable levels. For the European emission limits, it has set limits to sulfur content in diesel fuel about 50 ppm for the specifications for the Euro 4 since 2005, and it was updated to be 10 ppm according to the Euro 5 standards for the past decade. In 1996, the Euro 2, it was the sulfur limit was about 500 ppm for the diesel. Now in 2009, the Euro 5 had made it about 10 ppm in diesel. Why we are focusing also about the sulfur reduction? Because the WHO in 2012, according to the WHO records, approximately 1 in 8 global deaths were a result of air pollution exposure, making this the world's single largest environmental health risk. The International Agency for Research on Cancer has classified that the diesel engine exhaust is considered carcinogenic for humans, class 1. Nearly half of the above mentioned early mortalities are associated with outdoor air pollution. The main cause is the fine particulates. The vehicles are significant source of PM, particulate matter. In many cases, it is considered one of the major sources. To reduce the PM emission from vehicles, there is an urgent need to introduce the low sulfur fuels, fuels with no more than 50 part per million, and the ideally is about 10 to 15 part per million. Why sulfur? Low sulfur fuels are also necessary for the introduction and effective operation of the cleaner vehicles and emission control technology. This combination of the cleaner fuels and vehicles will have a major health benefit and deliver a substantial climate benefit through the reduction of short-lived climate pollutants, which like the black carbon. The lung cancer, about 29% of this is from this lung cancer, 24% of this is from the stroke, 25% from the heart diseases, about 43% of this is from the lung diseases. These are the implications and risks of highly polluted air. A fundamental implication of reducing sulfur is that the benefit are not limited to reduce the SOx emissions, but also to a host or the host of other harmful emissions. Once sulfur is reduced to adequate levels, there is then the possibility to introduce emission control devices that control other emissions than sulfur. Sulfur greatly impacts the performance of the emission control devices in vehicles, and it is also a catalyst poison and therefore compromises the control of the following exhaust emissions of concerns with like the particulate matter, the hydrocarbons, the nitrogen oxides, sulfur oxides, and ozone, and the carbon monoxides. So it is we have to focus mainly on one of the important pollutants, which is sulfur, to reduce its effects on the catalysts, the emission control devices, so we can reduce mostly all of the other pollutants. The urban atmosphere is subjected to large inputs of anthropogenic contaminants arising from both stationary sources and mobile sources, from industries, from power plants, from commercial and residential activities, and the mobile sources like the transportation. It is, we can say that the particulate matter is the term used for a mixture of solid particles and liquid droplets suspended in the air. Their chemical and physical composition depends on location, time of year, and weather. The determination of the chemical composition of particulate matter provides information about its origin, coming from where, the atmospheric fate, where it will precipitate, and the age, how long it will stay. The lifetime of PM10 is from minutes to hours, and its travel distance varies from less than 1 kilometer to about 10 kilometers. Here we can see the soot and fine particle matters from the diesel engines, wood stoves, power plant, and other combustion sources, which has been linked to asthma, heart attacks, and variety of other diseases. The particulate matter itself is composed of coarse particles, which have an aerodynamic diameter from 2.5 millimeter to 10 millimeter, which is coming from mechanical disruption, like crushing, abrasion of surfaces, and grinding, and the evaporation of sprays. The fine particles comes from the chemical reaction, nucleation, condensations, and which from gases which have dissolved and reacted. Here is the secondary organic aerosols, and the primary organic aerosols directly comes from the PM emissions and its combustion. the secondary organic from some chemical reaction in the atmosphere. The particulate matter then contains aluminum skates, oxides of crystals, fugitive dust from roads, fly ash, numerous organic other compounds, like the polycyclic aromatic hydrocarbons, like the normal, the nitro derivatives, nitro pHs, and the aliphatic hydrocarbons. The number of deaths from PM 2.5 exposure by region here for Egypt, it was about 90,000, and the number of this from exposure by 100,000 population by country for 2019. This is a comparison different countries in the world. The detrimental effects of air pollution for PM10 air pollution to health are well known. The ambient air pollution refers to air pollution in the outdoor area. Likely for the household air pollution, it refers to the air pollution originating in the household environment. The air pollution in the world is the world's leading environment risk to health, and it causes morbidity and mortality from diseases such as asthma, heart disease, stroke, lung cancer, chronic obstructive pulmonary disease, pneumonia, type 2 diabetes, and neonatal disorders. Most deaths related into ambient and household air pollution are caused by the human exposure to fine inhalable particles. In 2019, about 6.4 million have died worldwide as a result of the exposure to PM 2.5. 4.1 million from PM10 in the ambient air, and 2.3 million were due to the PM10 to 2.5 from the household air pollution. In 2020, cities around the world went into COVID-19. This led to noticeably surprisingly blue skies above them. However, in most cities, air pollution returned to its pre-pandemic levels almost as soon as restrictions were eased. This was a stark reminder of the need to strengthen efforts to tackle air pollution and to integrate air pollution reduction into the countries. Global health crisis further highlight the need for continued action in addressing a global and cross-cutting challenge such as air pollution. Some researchers suggest that PM 2.5 air pollution plays an important role in increased COVID-19 incidences and death rates. For the human respiratory tract, it can be separated into three sections, the upper, lower, and distal. Each section has its ability to filter the airborne particles based on their size. Particulate matter can be subdivided into three aerodynamics diameters. The coarse particles, which are defined as those having an aerodynamic diameter of 2.5 to 10 micrometer. The upper respiratory tract, composed of the nasal passage and the larynx, is the primary site for the deposition of the coarse particulate fraction. The fine particles, which represent the bulk of the ambient particle mass, its size range from 0.1 to 2.5 micrometer. These particles deposit on the lower respiratory tract, which is composed of the trachea and bronchial regions. For the ultra-finer fraction, its fractions are below 0.1 micrometer, which has the ability to be deposited in the distal respiratory tract. We can find here the upper respiratory, lower respiratory, the distal respiratory, and the deposition of each of these, the coarse inhalable and the fine inhalable and the nanoparticulate. Comparing a bowl, subparticulate shape versus a small bowl. The PM are characterized by its poor solubility but relatively large surface area. And it is this surface area component alone that is thought to drive the lung inflammation, which is integral process in initiation of number of lung diseases, which could be shown in the following figure. This is the size distribution of microns of virus types of atmospheric particulate matter. Each one is affecting a certain organ in the body. Here is we can find the normal alveoli, the overinflated alveoli due to the trapped air, due to the deposition of particulate matter, which constricts the airways and cause permanent damage to tiny sensitive air sacs. Some other compounds are the aliphatic hydrocarbons, which are introduced into the atmosphere by natural sources and the anthropogenic sources. The aliphatic hydrocarbons on the particulate matter. It comes from the vehicle exhaust, comes from the tire abrasion, comes from the brake leaning dust, and the road dust. These particulate normal alkanes are emitted in natural gas combustion, hot asphalt roofing, boilers, industrial boilers, from smoke from coal combustion. Also, the polycyclic aromatic hydrocarbons, other compounds, which are a group of compounds with a minimum 2 condensed rings. These are more. There is about 100 different pHs, and they are generated through the incomplete burning of coal, oil, gas, wood, garbage, and other organic substances. The pHs in the environment, it is quite difficult to ascertain them to a particular source. The pHs can be broadly separated into 3 non-exclusive categories based on their sources: biogenic, which is or phytogenic, which its origin is plants; petrogenic, from petroleum products; and pyrogenic, from fires and burns. The pHs have recently received a lot of attention due to their long half-lives in the environment, toxicity, carcinogenicity, and mutagenicity. This is the chemical composition of some of these compounds. The environmental occurrence of these compounds is primarily to atmosphere because of the direct release from both anthropogenic and natural sources. These pHs are found mainly soft on the particulate matter, but it also found in vapor state. Here is the fate and the transport of the pHs in the underground water, in the air, in the atmosphere, and there is different chemical reactions could be done. The group of pHs identified by the U.S. Environmental Protection Agency specified the following 16 pHs as carcinogenic compounds. Mostly one of the most important and dangerous compounds is the benzo-alpha-pyrene. Among these 16 pHs, 7 of them, like the crizine, benzo-alpha-pyrene, benzo-K, fluorescein, and dino, were classified as probable human carcinogens. The car fuel combustion, after its combustion, gives CO2 and H2O. The low boiling point components will lead to foundation of hydrocarbon emissions, and the pH formations on the PM, it will be found here, and it will be evaporated to the air as like a soot. This is the formation of the particulate matter, which is carrying pHs or alkanes. For Alexandria city, which has suffered heavily as the result of the large population in the city and the rapid urbanization and industrial expansion and increased utilization of fossil fuels in automobiles and trucks and public transportation. Also, the arid climate aggregates the high pollutant levels, resulting in enormous levels of suspended particulate matter. A study was carried at Alexandria to quantify the levels of the PM10 and the levels of certain organic pollutants, namely the particulate aliphatic and aromatic hydrocarbons, for the residential, traffic, and industrial areas. Here is the Alexandria pollution in 2022, exceeded about 5 millions. This is the total number of vehicles in 2012. Here is the study area for the industrial and residential and transport areas and traffic areas used for the study. Here is the filter papers. They used some instruments to quantify the levels of the PM10 in the laboratory analysis. Here is the filter papers after sampling from different sites, the particulate matter and the chemical compounds. Most of the PM10 monoxides were mainly influenced by traffic emissions, busy roads, streets, canals. The average temperature, the average humidity, the wind of direction, the wind speed during the study. It was found the traffic sites levels of PM10 range from 27.5 microgram meter to 41.5. For the residential areas, 15.5, about 15.5 to 23.8. For the industrial, from 83.8 microgram to 99.5 microgram. The industrial particulate matter was the major source of particulate matter for the industrial regions. After it, the traffic, after it, the residential areas. This is the average percentage for the PM10. For the aliphatic hydrocarbons, it was found the average particulate alkanes was about range from 15 to 187. For the residential areas, ranged from there was an average about 373. For the industrial, it was an average of 1076 nanogram per meter cube in industrial areas. For the polycyclic aromatic hydrocarbons, for the selected sites, it was obtained that the pH levels was 9.7 to 69.4 with an average of 34 nanogram. The average summation for all of the pH particulates ranged from 500 to 543 nanogram with an average of 518 nanogram. It was found, it's expected that the vehicular emissions are the major source of atmospheric pHs. Here is the pHs families after differentiation between them. We found that 4-ring pHs have represented about 46% to other pH. Here is the distribution in the industrial sites. The 4 rings represented mostly the most predominant compound found. Here is for the traffic sites. The chrysene represented about 28%. For the residential sites, the chrysene was about 41%. The pH here, this graph shows the pH plus of diagnostic ratios, the anthropocene versus the fluorescein. The calculating uses data levels of pH congeners. Mostly comes from combustion sources and petrogenic sources. The correlation of PM10 content and average particulate matter in normal alkanes were shown here. We have found the maximum value of benzo alpha pyrene recommended by the WHO is 1 nanogram per meter cube due to its carcinogenic property. The average value for pH in the study was 2.16 nanogram, greater than 0.26 nanogram found by Propi and Santiago in Campo Grande in 2004, and it was almost two times lower than that 5.75 found by Wang in Nanjing. The conclusion from this paper is that the values of PM10 determined violated the WHO guidelines threshold in many occasions, especially at the industrial and traffic sites. The average PM levels was slightly higher in summer than winter. This is because mainly in the traffic sites, this is may be attributed to the dense vehicular traffic during the summer season. The study confirms the contribution of vehicular traffic and industrial emissions and the various combustion sources of PM10, normal alkanes and particulate pHs. The spatial distribution of pH, temporal variation, and source apportionment results indicated that the vehicle emission, especially from diesel-powered engines, are the major sources of pH. The cancer development as a result of exposure to pH via inhalation is not negligible and should be taken into account for health protection in future. The recommendation is to encourage the researchers to evaluate the pollution of Alexandria city and to make monitoring program for the air to find out the variation in different chemical physical parameters in order to identify the main sources of pollution and to find the best way to control it. Also, for the recommendation, building up a gaseous pollutant monitoring network that covers all of Alexandria in order to enable the gaseous pollutants phenomena on a large scale of land. These stations must cover not only the pollution in the atmosphere, but also sources of emissions of its precursors. Also, number three, a recommendation, carrying out an environmental strategic impact assessment prior to any major project and to follow up the impacts and over all roads. Also controlling on the fugitive losses from automobiles, industrial valve pipes, storage tanks. Also, one of the important recommendations is the replanning of the traffic management. Thank you for your attention.